Next up is Riyad Mucadam. He started his PhD in 2008 in Earth Science. He changed his topic in 2009 to an interdisciplinary topic, biological materials, that bridges applied physics and biomineralization. Riyad speaks Marshallese and Urdu. He supervises our Associate Professor Catherine McGrath and Associate Professor Michael Hanna. Please welcome Riyad.
What if you want to build a structure that is efficiently built, that allows a good deal of light to diffuse through its various interconnected spaces, and that is strong, such as a grand yacht, or which also allows fluids such as air and water to mix, such as in a photobioreactor for growing algae? Well, to find a bio-inspired answer to this question, I am studying the architecture of the growth stages of a single-celled marine organism that in its adult stage looks like a spaceship. Using electron microscopy, spaceship let me show you how I built my skeleton out of single crystals of calcium carbonate, the same stuff your bones and teeth are made of at our shells, and how I put them together out of seawater. I also use a membrane that is laid out over the crystals like a thin mat. But the amazing thing is that these crystals become beams, which expand to become chambers, which become pipes and pores. In these chambers, I have within me algae, and the roof allows light to diffuse in through various spaces. Now, we want to look inside this spaceship, that spaceship. So we use X-ray tomography, the same technique used in the hospitals to scan our body, to look at its skeleton in 3D. This allows us to look at a real representation, precise representation of this at different angles. You can slice through it. You can even walk through it and isolate features. This means that we can also calculate using software various geometric parameters, such as surface area, volume, distances, angles. But the real kicker in this is that we can actually see in 3 dimensions what was not possible before. We can see how all the micro features are actually put together. This means that we will be able to get a visual, a geometric, and a limited chemical understanding of how its structural design may help spaceship function efficiently as a photobioreactor. Thank you.
If I can comment on behalf of the judges, I thought it was a very varied and dynamic presentation, but I thought it exhibited well your passion for the line of inquiry you're on. And in that regard, as a non-scientist, I feel that you carried me with you in terms of I can step back and understand what your questions are, what your method is, and more importantly, what the significance and the application of it was. It's a very, very good presentation. Thank you.
Sweet. Thank you.